Welcome to this presentation on the CQRS pattern in C#, also known as Command Query Responsibility Segregation. Today, I'll walk you through how this powerful architectural pattern can improve your application's scalability and performance. Let's start by understanding what CQRS stands for. It stands for Command Query Responsibility Segregation. In simpler terms, it means separating operations that write data from those that read data. By doing this, we can optimize both reading and writing independently. Why should you care about CQRS? Well, it offers several benefits. First, scalability. You can scale read and write operations separately to handle large amounts of traffic. Second, performance. Queries can be made faster by optimizing how you store and access data for reading. Third, it keeps your architecture clean and maintainable by separating concerns. And finally, CQRS works well with event sourcing, which helps track data changes as events over time. This diagram illustrates how the CQRS pattern separates commands and queries for better scalability and maintainability. We start with a user request, which can either be a command to write data or a query to read data. On the left side, we have the command side, also known as the write model. The request is processed by the order command handler, which handles operations like placing or updating an order. The handler then stores the data in the write database, which is optimized for fast and consistent data writing. On the right side, we have the query side, also known as the read model. The request is processed by the order query handler, which retrieves data from the read database, specifically optimized for fast reading and complex queries. By separating these two responsibilities, we achieve better performance, maintainability, and flexibility, especially as the system scales. Now let's see how CQRS works in a simple C# order management system. We'll break it down into two parts. First, placing orders using commands. Then, fetching order details using queries. We begin by defining a command to place an order. In this example, the placeOrder command class has properties for the order ID, product name, and quantity. This represents the request to create a new order. Next, we need to handle the command. The order command handler class processes the command and stores the order in an in-memory database. Notice that we check if the order ID already exists to prevent duplicate entries. If it's valid, the order is saved and a confirmation message is displayed. Now, let's define a query to fetch order details. The getOrderQuery class simply holds the order ID as a parameter. This class will request the details for a specific order. Next, the order query handler processes the query. It searches the in-memory database for the order and returns the result if it exists. If the order isn't found, a message is displayed saying so. Now we bring it all together in the main method. First, we create an instance of the order command handler and use it to place an order. Then we set up the order query handler, passing in the in-memory database. Finally, we query the order and display the details if found. This demonstrates the clear separation of write and read operations in CQRS. When we run the code, this is the output. Order 1 placed successfully, followed by order details. 1, laptop, 2. As you can see, the command and query operations are handled independently and cleanly. To wrap up, here are the key takeaways. CQRS separates read and write logic, which improves scalability and performance. It helps maintain a clean architecture and works well with event sourcing for complex systems. Thank you for watching. Don't forget to like, subscribe, and let me know in the comments if you'd like more tutorials like this. See you next time.